Welcome everybody to our webinar session. We are very excited about having you today. We will start soon, but first we will mention some points related to the organization. Your microphone is on mute. We will keep this feature as it is to provide an organized session to avoid background noise and interruptions during the presentation. However, we have a messenger option. In the bottom of the screen, you will see an icon. You can submit written questions by typing them in the question box in your control panel. We would like to have an interactive session and discussion, so please feel free to send your questions. You may send them at any time, and we will collect and address them at the end of the presentation. In case the presentation takes longer, we will extend the session 15 minutes so we can discuss your questions. You will be able to count with a presentation that will be shown during the conference. It will be sent by email on PDF right afterwards. Now, I would like to introduce our speaker. Mr. Giorgio Palanza is New Business Development Manager at Tyre Recycling Solutions. He holds a master's degree in chemical engineering at Politecnico di Milano and also an MBA. Giorgio started in technical sales and market development roles in companies in the polyurethane business, focusing mainly in the footwear segment. About the company, Tyre Recycling Solutions was founded in 2013 in Switzerland with the aim of enabling sustainable recycling of the materials contained in scrap tires. The company has developed technologies to process scrap tires and deliver output products with significant value in use, providing cost-efficient new materials and unique compounding solutions. About Weibold Consulting, the company was founded in 1999. Over the years, Weibold gathered an international team of experts and established a large professional network involving researchers, decision makers, and authorities. This enables Weibold to receive first-hand information about markets, new products, and innovative technologies in the field. In addition, Weibold issues a free monthly newsletter on tire recycling and pyrolysis, which relates to all aspects of these industries and provides unique takes on the newest development and trends. We hope you enjoy this session. Giorgio, please, whenever you want.
Okay, I'm on. Good morning, everybody. Let's start. As Augustina already introduced me, I'm in charge of new business development, and I've been working on projects to introduce TyreXol rubber powder. TyreXol is our brand in different downstream applications. I've been working on this since 2016. Such activities in line with the mission of TRS that was already mentioned by Augustina, that is to build profitable and sustainable global solutions for recycling end-of-life tires, implementing new technologies, innovative business processes. We have been working on different projects. We got also the attention of the Solar Impulse Foundation recently with an acknowledgement, but we have to mention the footwear project was one of the most important after the reintroduction of TyreXol into new tires. All these results that we are presenting today in this webinar coming after years of studies in marketing and R&D, both internal and with third parties. Let's move on. The next slide. It's somehow a provocation here. These are sandals and that are produced by the Maasai tribes and population in Central Africa mainly. Somehow funny, but it's a good kickoff for this webinar, which is actually focused on how to evolve from this, and with a presentation of processes and scale up and technology to go to an industrial scale. Next slide, number 3. the main topics of the webinar. I will start from the tagline and be precise and accurate on this. We want to understand how to formulate our TyreXolCW rubber powder and maximizing its use and make out of it sustainable shoe soles. CW stands for car water jet. We divided the presentation in three blocks of topics. The first block will be the introduction of TRS, the company and technology, and TyreXol rubber powder. The background for these trends and the rationale for using TyreXol into footwear. Second block will be a bit more technical with involving the presentation of our results in rubber, in polyurethanes, and thermoplastics, with a case study on 3D printing. And the last block will cover cost aspects and EH and S aspects that are really important for the manufacturing of footwear. With, at the end, our conclusions. To be said that a lot of work has been done at TRS, but also in other companies on tires and how to recycle rubber powder on tires. But footwear is the second largest market for rubbers after tires. So we want to really incentivize the use of recycled rubber into the footwear segment. Next slide, number 4. It's on the assets and the locations of TRS. From the pictures, well, our building, our plant with solar panels providing energy, brand new. A detail of the inside is part of our post-treatment plant after the water jet. The stock in and the stock out. Stock in are incoming end-of-life car tires mainly. Stock out are bags, big bags of the powder we produce. A note, a remark on the logo. We are, since December last year, certified ISO 9001. It's a standard for the industry segment where TRS is planning to operate. Plus, then the map showing the Switzerland, where we are. The plant is located in the area of Neuchâtel Lake, while the R&D and administrative office are closer to Lausanne on the Lake of Geneva, on the Lake Leman. Next slide, number 5. We present here the business model of TRS, which is key for this webinar and the evolution of the implementation of TyreXol into applications like footwear. First of all, the production, the assets. We have our own plants that we just shown, we've been showing, plus the hubs. We have already a plant starting in China this year, and the next on-stream plants, licensed plants, will be in Eastern Europe and in the Middle East starting next year. After that, the role of TRS, not just selling the equipment, but acting with licensor and interacting with off-takers. We have an off-take agreement with our partners. We take care of the production process that should be conforming to strict quality standards. The plan is to implement the ISO certification in all plants. And the idea is to go always in the direction of customers and meeting their requirements locally. The third aspect, the third step in the business model is the rubber powder itself. We aim to have a constant quality everywhere with a global availability provided by the geographical position of our plants starting next year. With on top of this global reach, anyway, the centrality of the TRS lab and headquarter in terms of competences and technical support for the quality of the powder. Next slide, number 6. A glance on the technologies. We start from scrap tires, mainly from car tires today. We start in the lower part, in the higher part of the screen with the sorting. This stream is for the TyreXol water jet. We call it water pulse. The sorting then foresees the introduction of end-of-life tires in the T-cut. The T-cut is our patented solution to make the tire in 3 flat parts. The tread is treated with our patented water pulse technology, which is a water jet acting, a specific water jet operating at above 2000 bars, which at the end, after a process of dripping, drying, and sealing, is generating a product that we call a CW, it's a car water jet, that recently is also accompanied by the TW, so the truck water jet. We are starting to apply this technology also on truck tires. But then the other stream on the bottom of the screen, of our screen, is concerning the qualities. On top of, out of the fork at the T-cut, we can operate on the residual of the flattened tire that cannot be treated with water jet. We put it together with a mixed fit of other kind of tires. We then implemented a solution, SGGM technology, shredding, granulation and grinding and micronization, which at the end of the process of sieving is leading to a TyreXol quality mechanical mix that can be further treated with a chemical activation and create an MMA grade mechanical mix for asphalt and bitumen applications. On the next slide, then here we present the lab capabilities, which are really a pillar of TRS strategy and the business model, supporting us in developing our so-called compounding intelligence of materials. We go downstream with solutions, also at compounding level. The lab is composed by a part of compounding, including roll mills, a Banbury mixer, and specific rheometer and viscometers. We have then another part, other rooms for the chemical and mechanical testing with instruments to measure the tensile, the infrared and the UV spectroscopy, the abrasion. Plus, we have other 2 small parts in the lab. One is related to bitumen for the asphalt and bitumen solutions, and a microbiology laboratory, which is an R&D step that we are following for a biovulcanization of rubber. In the lab, we have 4 people. 2 are lab technicians. There is a PhD, a product specialist for compounding, and the head, our R&D manager. The next slide is meant to explain the differences between TyreXol and the conventional rubber powders available on the market. A glance on the water jet rubber powder on TyreXol and its comparison with other powders. Water jet is TyreXol is somehow a flake, it's a fluffy appearance in the containers. We compare it with a mechanical or ambient powder, which is somehow more irregular as morphology, and with the cryogenic, which is a faceted mineral-like aspect. This morphology, I will cover it later, but first I want to focus a bit on the composition of TyreXol. This flake that we introduced before as is a stable composition because it's coming only from car thread. That is, there is a high content of silica, and there is also, and this is constant for all rubber, recycled rubbers from tires, the black color that is given by the carbon black is still there, giving a coloring effect. Coming back for a second to the morphology or the metrics on the morphology, we measure it with a gas absorption, it's called a BET, and we see that comparing TyreXol with cryogenic powder, there is the double of the surface available and 50% more if you compare it with a mechanical powder. This measurement is confirmed by the related chemical activity measurement with iodine. And it's actually measuring the real potential for bonding. And what are these differences doing? Well, we will demonstrate that these differences are yielding and creating different level of performance in compounds. Next slide, number 9. Again, on the composition, we measure it different times over time, and we see that it's really, really constant. Considering that the product is chemically active and with a constant composition, the claim, the idea we have, the practical aspect is that we want to propose it as a formulated raw material to be formulated, and not just as a filler for any metrics. After this particular on the peculiarity and composition, next slide, number 10, is covering the sustainability of this powder for specifically also for the footwear segment. The source for the, let me say, the car thread part, the powder from car threads is an unlimited source. Every year, there are more than 1 billion end-of-life tires available. And what you can see from the picture, apparently, yes, it's a landfill, it seems ecological disaster, but we want to see it rather as an opportunity, as raw material. Coming to the aspect, the sustainability, not from the raw material side, but from the carbon footprint. We went and seen into literature what are the levels of the carbon footprint in normal virgin neat raw materials, and what is the impact in CO2 emissions of recycled rubbers, and including TyreXol. And it's evident that the impact in terms of carbon footprint of recycled rubber is much lower, and it's less than 1,000 kilograms of CO2 per ton versus the above 3,000 kilograms per ton of the virgin raw materials. It's an average. So even in the most CO2 containing case, the use of rubber powder, TyreXol, is and its substitution in polymers for footwear is an advantage in terms of carbon footprint. Going to the next slide. What are then the industry trends and requirements, the rationale for our activity? First of all, the 3 megatrends, the effect of the presence of Greta in the media, that just generated strong awareness and of the impact of the anthropic effect, and started to create then a focus on a circular economy in place of a linear economy. The most recent effects of pandemic that experts say that are polluting also into into the environment and creating issues and potential contaminations, cross-contamination, plus the effect of deglobalization. That is a stretch of the reshoring of industrial activities. There's a strong focus on using local districts, local resources. Then what is supporting use in footwear and in the market, from the market point of view? A Me Too effect. The early adopters are generating a domino effect. So everybody, once someone is saying that it can be done, it's successful, then they want to follow. And then a bottom-up effect of end users. They made the B2C approach influencing and leveraging the B2B, and also in the manufacturing of footwear, there is a need of something sustainable coming from the basis of consumers. More specifically to the requirements in footwear, now there is higher attention to specifications that should be functional and not just simply dictated by historical data sheets and specifications of producers of natural or synthetic rubbers, plus a higher flexibility to compromise the requirements and in terms of mechanical properties, and also maybe color. And now the fashion wants white, clear color shoes, but now if you use recycled material, dark color, black color prevail. And but this is acceptable. It's starting to be acceptable. It's a compromise. It's accepted. To be mentioned that there are already plenty of companies that are working to produce sustainable footwear. Brands like Indosole, On Running, Adidas, Everlane, they work a lot in this direction. But it's also true that they focus a lot on the shoe uppers and not on the shoe sole, that has a different level of recyclability. Next slide, number 12. First page out of 2, a summary. So why using in footwear? Well, we clarify that the carbon footprint is lower, is an advantage. But then from a cost perspective, recycled rubber is and will be less expensive than the original polymers. Then another aspect is, other two aspects I would say, the ecological shoe soles can be recycled again. If you have rubber in, depending on the technology you use, but you will be able to recycle them again. And then the compatibility with the bio-derived products. Bio-derived rubber, polyols are just complementary elements, in this case, to the wide sustainable concept for footwear. Next slide is number 13. Going into details for the polymers used in footwear and TyreXolCW, how it be fitting. First of all, in rubbers, there is already a use of internal scrap recycling. Most of times is reclaimed scrap, or less frequently grinded, but it's used by itself. It's not making a shoe sole sustainable. Other aspect is that these reclaimed products this internal loop is not unlimited. The reclaim is not 100% of the raw material, and the target in a company should be to have zero scrap. What is then the importance of TyreXol? It allows to have a higher compounding on top of the internal reclaim, higher compounding level versus the standard regenerated products within specification or requirement of the shoe sole. Going to polyurethanes that we tested already, we have seen that there are synergies that are possible in a polyurethane matrix of TyreXol, and it's in line with the ongoing efforts for recycling polyurethane in the physical mechanical way, not in the chemical way. Coming to the TPE and specifically TPU, we've been working on synergies and compression set, the adherence. These are also aspects that are possible in TPEs, but not marginal is the aspect that thermoplastic is the recyclable product for excellence and of excellence. And so having said this, I would say advantages are possible in any family of polymers used in footwear for TyreXol, for a company with TyreXol. Next slide is number 14. We open here a chapter concerning the outcome of different tests according to the previously families of polymer as matrices. We start from rubber, slide number 15. How we approach the problem, we first of all, we use the 50 mesh granulometry, is a 0.400 microns of TyreXolCW. The reason is that industrially we have the maximized output of the plant, but the other reason is that the grade that is more commonly compoundable in rubber compounds. We have been then choosing a formulation. It's a composition coming from literature for shoe soles that has been validated by consultants and industry experts. How we operate, 2 steps. In the first step, we put all ingredients in the memory with a silanization in situ. Second step is a roll mill, and at the end, the vulcanization, the curing is made at 160 degrees. Then we started measuring first the indicators of the processing. The T90 is a measure of through the MDR, the moving diameter, about the torque. We see, we plot in the 2 axes the minutes for reaching 90% of the maximum achievable torque. And then we, on the x-axis, we have the degree of loading of TyreXol rubber powder. We start from a 20% up to a 50% maximum loading. We see here that the process is slightly faster. Maybe it's positive, depends on the requirement of cycle time into a factory. Then measuring the MH minus ML, so the maximum and minimum torque difference. It's a proxy of the degree of cross-linking. We see that it's slowly degrading at higher loadings. We have to say that these are all composition-dependent solutions, and an adaptation and fine-tuning is always possible. After we've seen the processing, we've been then comparing the actual properties of the performance. So starting from the tensile, we have on the y-axis the tensile strength, and again on x-axis we have the loading. And well, fantastic. It's TyreXol is not only negative, but is also creating higher tensile. Tensile is the variable, the factor that is most time the first that is taken into account by producers. And extending also this analysis to the hardness and measured in show ray, always plotted against loading, we see that even the hardness is not impacted by TyreXol. So definitely we have a positive effect of TyreXol. Then going to analyze other aspects in slide number 18, what's happening to the tear strength? Tear strength is slightly decreasing, but still in range for loadings between 20 and 40%. It's measured in kilonewton per meter on the y-axis. And then very positive is the abrasion. The abrasion, the lower the better, and we see that even higher loading, the abrasion of the shoe sole is reduced. So having considered these 2 points, and a conclusion in itinerary is that the addition of 20 to 40% of TyreXol is really doing okay for shoes. So with this formulation, there is a possibility to create a positive effect and not a negative effect as one would expect. Then we analyzed what's happening in a common case of shoe sole producer already using internal reclaim and focusing a lot on them. So we kept the same formulation. We added the one ingredient, and with the idea really to understand if any synergy is possible, and if this paradigm is only internal scrap is good. So we kept a 30% loading in the formulation. We have seen that it's good, and then we made vary the TyreXol and reclaimed rubber from Footwear into this range of maximum 30%. Trying the follow from 0 TyreXol, 100% TyreXol, 0 reclaim, 100% reclaim. So within these ratios, we have then been going to next slide 20, to measuring what's happening with 30% of recycled material in a footwear. Again, the plots are similar with the tensile strength megapascal on the y-axis. The tensile strength is improving once you start using TyreXol. And measuring also the abrasion, the important parameter, you can see that the abrasion is decreasing. So the effect of TyreXol in the mix is definitely positive. As synergy, there is good evidence that the synergy is possible, and TyreXol is just increasing the possibility of using recycled material into footwear. And at the end of the day, to maximize the total content of recycled material into shoe sole. Next slide. The question we ask is, we wonder is, what's happening if we compare rubber by rubber type? And sorry, it was a bit slower. And so we made a sort of one-to-one comparison, or 100% regenerated material, including TyreXol, the control reference sample, the mechanical powder, not analyzed before, and the reclaim. Always working at 30%, we can see that with this formulation, TyreXol and an adaptation of abrasion, of course, is good, the blue line. TyreXol, in all dimensions we measure it, is performing even better than the reference sample, with just the exception of the elongation at break in case of the reclaimed rubber. Now, next slide, we will move into the polyurethane compounding. It was a sort of challenge. The point here is how to mix liquid resins and solids. It's possible, just requires a suitable equipment to do it. The ideal technology is having few equipment suited for the mixing of solids. There are in the market, there are producers like Gooseby, Desma, Niagara that are proposing this equipment for the cork, synthetic cork, cork imitation footwear. And as a secondary options is less seducing, would not be the first choice, is a dispersion or a suspension of TyreXol rubber powder into the polyol. We made a test then, and we designed the experiment using always the CW50, the 50 mesh grade. We used the mechanical powder and the cryogenic powder as benchmark. The choice for the polyol or the PU basis was a polyether, and we decided to use a vacuum mixer to better simulate the operations in a production equipment. After that, we went to characterize the different plates that we obtained. Next slide, number 24. What was the approach? Well, we started with a drop-in test. We made no check of the ratio of the stoichiometry for polyurethanes, and we decided we approached to mix TyreXol in the polyurethane in this case is at 20%, and see what happened. We could notice that the compound with TyreXol was performing better than a neat polyurethane. This is somehow unexpected. But then checking the elongation at break, we noticed that with TyreXol in the compound, it was really high, and that was even more unexpected. First of all, so the assumption is that probably the plate, the tech data sheet ratio was not respected, and the stoichiometry had to be respected at this point. But the fact that the elongation and break was so high, it was for us a demonstration that there is high interaction in the polyurethane matrix. Then continuing the same approach, we then measured what's happening in this drop-in approach with other rubber powders. We have then measured the tensile strength and the elongation, and we have seen that other rubber powders, both the cryogenic and the mechanical powders, are behaving rather without interaction in the matrix, as it was seen for TyreXol, and without probably any bonding. So more with a filler effect rather than a composite effect that one could assume for TyreXol and polyurethane. Then the point was, let's close the loop on this kind of blind experiment and work within stoichiometry. So once we measure the tensile strength with the adapted stoichiometry with the right ratio, we see that the tensile strength of polyurethane is back to the expected behavior. But the elongation at break is still better when you have TyreXol in the compound. And what is then happening to other properties? And we see that also the steel strength, once you have the TyreXol in the compound, is improving. So the conclusion in this case is for us that there is a possibility to match the performance of polyurethane, but a reformulation of the PU mix is needed. And this will be what we tested is actually the first step in polyurethanes. Next slide, slide 27, we have here what's happening once we compound with TPU in a thermoplastic. We made this test with a third party, and we tested 10 and 20% loading. Really good aspect is that the hardness is not changing that much, and also the elongation at break is still very good at 20% loading of this neat TPU. It's a TPU that is specifically tailor-made for shoe soles, for footwear. But we had to notice that the tensile strain and the abrasion presenting a change versus the neat that are above 20%. Clearly, it's the two solid phases in the composite can be working together, but other changes are needed. Either it's possible to work on a TPU formulation itself, or still aiming to obtain other properties, improving properties like the compression set or the grip on wet ground. Then one should adapt to work in a compromise compounding of 15% in order to be in a reasonable range of tensile and abrasion. Then, after this test, I would like to introduce you to a video that is representing our efforts in the formulation of TyreXol in 3D filaments for 3D prototyping. 3D prototyping in our today discussion are meant really to create a simulation of the touch, of the shape, not really of performance, because 3D printed articles are not comparable to injection molded articles. So hope you liked it. Then a few slides covering the economic aspects of TyreXol in compounding. It's not a marginal aspect, but it's required to confirm the value proposition that once we have seen that the carbon footprint is okay, the performance is okay, it's important to assess also what's happening in case of the financials. And covering the rubber aspects and considering a price assumption for TyreXol less than €1 per kilogram. We can see that if you have 1.5 kiloton plant or even 4 kiloton per year plant, if you can formulate TyreXol in a proper formulation at 40%, for instance, you can go achieve a 40%, up to €1 million savings, and 400,000 in the same case if you have a smaller plant or if you have a smaller capability to absorb TyreXol in your formulations. Then, taking an example coming from tires, the tire business say they want to use internal scrap, and there is nearly no cost for internal scrap or reuse. It's very cheap, but then the limit is that they cannot go beyond 3%. And while with TyreXol, you can go really high, and even in tires with respect to the conventional recycling ratios. So the key message here is that the price per kilogram is misleading, is a trap. The savings in a formulation, in a compound, are happening only once you can really formulate with high quantities of recycled material. And only there you can make savings, still keeping the performance, of course. Doing the same assumption with keeping the same approach for polyurethanes that we have seen and TPUs, considering a 30% loading in polyurethanes and a 15% in the TPU case, and using historical prices for those two polymers, we can see that savings are possible up to 18% in a polyurethane and a 13% in a TPU. The message is the same of the previous slide. The more you add, always having a cheaper price, but the more you add the cheaper price than the virgin material, sorry. The more you add and the more you save in the final cost structure of the shoe sole. A few slides now, a couple of slides, let me say, on aspects that are also important for shoe sole producer are the EHS, so environmental health and safety. These aspects are coming out, especially when the material coming from another industry like tires is compounded with products conceived and designed for footwear. In this table, we compared the measured values of polyaromatic hydrocarbons found in TyreXol with the limit given by REACH and the limit given by GS, the Geprüfte Sicherheitsstandard, considering a dilution of 20%. And we could see that in this case, given by the dilution, but given already the low content of polyaromatic hydrocarbons in the thread, the formulation of the thread, the two standards are met. You can see that this formulation also was coming out of different tests. So the stability of the composition of TyreXol is confirmed also for the undesired impurities over time and at ppm level. So this is in compliance. Another aspect that we have seen is compliance is the environment, the Annex 14, what's happening for the SVHC, so the substances of very high concern. again, there are four groups, the polyaromatics, metals, phthalates, and phenols. There is no requirement for authorization. All values are within the limits, and so with the previous slide and this slide, we could say TyreXol is okay in terms of EHS for reformulation in footwear. This slide number 35 showing where we are now in terms of presence in the market. You see the flags. We have sales and advanced projects in the area, in the districts of the production of footwear: Spain, Italy, Vietnam, and China. Unfortunately, we cannot give details on the projects. There is high IP and confidentiality requested by producers, so no pictures, no details about that. But definitely, TRS is having a good reach at global level also for footwear. Last point, last slide is our conclusions and the perspective. So we demonstrated that high savings are possible. There is no loss in performance with a tailor-made formulation that we used, and there is a strong carbon footprint reduction. But on top of this, in terms of perspective, this is achievable at global level with a business model of TRS. We are proud to propose something that can be used in all parts of the globe, of the world, and meeting also our vision, is confirming the vision we have, so that to reinvent the tire recycling and transforming waste tires into a valuable resource. So that's it.
Thank you very much, Giorgio, for your presentation. I'd like to share with you some questions we've received from our attendees. First question: if we use OTR units, can we increase the value of the final product because of the higher NR content in OTR?
We are working in the sense, the point is that OTR needs to be, in order to be formulated as we did, needs to be recycled through a water jet. And only water jet allows this level of compounding, because at the end is creating this specific morphology that improve the interface activity and therefore the compounding properties. So we are working also in this case, in this sense, and we study now with trucks, but we are also developing OTR water jets suitable for OTR.
Thank you, Giorgio. Next question: are the shoes heat resistant?
Can you repeat? Are the shoes?
If they can resist very, very high temperatures.
Well, like normal rubber, we never measure the resistance to heat. We normally are measuring the aging, but at the end, after the vulcanization, there is and all the metrics we make after the vulcanization, there is no aspect that make the shoe soles behave differently from a shoe sole made only with virgin rubbers.
Thank you, Giorgio. Next question regarding slide 14 or 15. Could you please repeat the particle size distribution of TyreXolCW50?
It's 0 for 100 means we can provide a technical data sheet. 400 is the maximum in our specifications. The D50 is the size of the 50% of the total composition of the granulometry in the granulometry, and is less than 200 microns. So we have a sort of Gaussian curve in the distribution of the granulometry. And so it's very comparable, let me say, in terms of activity with a smaller size powder coming from either mechanical or cryogenic process.
Thank you, Giorgio. Next question. Could you please tell us about the contaminations regarding ash and organic content of powder rubber?
Concerning ash, most of ash is coming from silica. Since today we are working, as I mentioned in the slide, we are mainly working with the car tire tread, and the car tire there is much less carbon black and more silica, and the silica is then to be found into ashes. For the organic part, organic is a polymeric part. So if you have in mind some specific component, the polymeric part in total is still 48% in average, and that would be the organic part itself.
Thank you, Giorgio. Next question. Do you do downsizing of your tires at your facilities, or do your tires come directly downsized?
The downsizing is the ticket for us. So the tire are entering the plant as waste, end-of-life tires, and we are not cutting, we are not making any pre-treatment of tire, mechanical pre-treatment. Our production plan is integrated. You insert the end-of-life tire in the plant, in the ticker, at the plant, at the beginning of the plant, and on the other side you got the separated powder, steel, and fibers.
Thank you, Giorgio. Next question. If I properly understood, you are using the rubber powder TyreXolCW 50 directly into the shoe soles composites without using any other additives. Is that right?
Yes, we are not pre-treating the powder. The only trick, let me say, or the only activity we are making is the curing package that has to be adapted both for the processing and also for the vulcanization. But in terms of technology, is a drop-in technology. So it's a solid polymer like the natural rubber and then synthetic rubber, and they entering the bamboo remixer exactly without any pre-treatment. It's just coming out as TyreXol and rubber powder after drying.
Thank you, Giorgio. One more question. What would be the cost to produce one pair of shoes?
Well, I was not doing some kind of this kind of activities, probably an exercise for the audience, for someone in the audience, but clearly the impact, if you can add, let me say 40% of TyreXol, today the indicative price of TyreXol is below €1, and average price of a rubber compound is €2. So I think that you can reduce the cost, as in the slide, one of the final slides, probably by 20–30% in terms of raw materials.
Thank you, Giorgio. Next question. What is the potential of powder rubber in tire production?
Well, it's it's a good question, and actually, we would like to challenge a bit more the tire producers because their paradigm, as we have been showing the cost projections, the paradigm is using 2-3% of internal scrap tire. Today, our focus would be for certain kind of tires to reach at least 10%. But obviously, the key is to stay within the tire requirement specification. So it's a 10% with all the parameters respected. So this is our potential, let me say, focus.
Thank you very much, Giorgio, for your presentation and also for this Q&A session. And thank you, everybody, for taking part in this webinar. We would very much appreciate if you could help us keep our service relevant by giving us your feedback. So we will send you a form with a few questions very soon, and also the presentation that was shown during the conference by email. If you want to learn more about these topics, please kindly note that we are issuing a free tire recycling related newsletter once a month. And also in our Weibold Academy section, you will find a wide variety of articles that highlight the different aspects of managing this business. If you have any questions related to the webinar session or Weibold Consulting Services, please do not hesitate to contact us directly. We would like to support you and discuss your specific needs. We are looking forward to seeing you at our future webinars. Thank you very much and have a nice day.